Hello, my name is Larissa Reeve, and my group consisted of Jana and Mehedi. Jana and I will be presenting on power plants for the island of Electra today. So, a background, the island of Electra was recently discovered in the South Pacific, and it's shown here. It's got about 1.5 million people, and most of them are concentrated in the city of Port au Stance right here. There's the Chansey River and 2 factories. Our job was to implement a power grid for the island, and our group chose generation because we wanted to understand more about generation power plants and how they work and the way they interact with the environment. The island, however, lacks natural resources that do not produce electricity, so that issue was considered when looking at different types of power generation. We were given the information that the island had a base load of 500 megawatts and a peak load of 1,800 megawatts from 3 p.m. to 5:30 p.m. and a topographical map that split the region the island into 3 regions as we split it here. And each region was required to supply 600 megawatts for each third of the island. And our group chose Region 2, which is the northeastern region here, for the renewable energy opportunity that was there. And we will go through some of those generation types that were chosen. So, as you can see, here are world electricity generation percentages and the types of generation. Coal and coal products were number 1 with about 40%. However, we didn't choose coal to investigate because it's dirty and the electrons are environmentalists, so we wanted to stick to cleaner energies. The next 4 generations, power generation types, were chosen though, and geothermal. So we chose hydroelectric, nuclear, geothermal, wind, solar, and natural gas. And out of those 3, we decided that hydroelectric, nuclear, and geothermal were not good for the island, and we'll go into more depth about why, and we will go into more depth about the wind, solar, and natural gas that we chose for Region 2 of the island. So the first generation type, which was hydroelectric, shown here, the Chansey River could be utilized for this, and there was a 90-meter drop on the river, and that would be where the generator would be located, with a reservoir at the top and the generator at the bottom. And during the day, the water from the reservoir could come down into the generator, and it would push through this turbine and generate power. And then during night, the water would be pumped back up into the reservoir to fill it up. The equation for output power for this is the efficiency times the density of water, gravity, height, and water flow. And we are assuming 100% efficiency for our maximum output power, and we had the 2 dependent variables, which are 90 meters as the height, and the water flow, which was 20 meters cubed per second. And our maximum output power was 17.66 megawatts, which is only 3% of the needed power for the third of the island, which is 600 megawatts. So because of the low output power and the fact that with the reservoir it can flood the land around it, and it can dry out the river below the generator, we decided that hydroelectric wasn't a good option for the river or for the island, and it was on the wrong region. So I'm going to turn the time over to Jenna to go over a few more of these generation types.
So I'm going to talk about nuclear. United States is as known as a pioneer of nuclear power development in 1960, and the most common of nuclear reactors in that day is pressurized water reactor and boiling water reactor. So I'm going to talk about how the nuclear reactors works. So generally power plant use steam from heated water to power up the turbine and produce electricity. The heat is come from the nuclear fissions that split bigger atoms to release energy, and the most common power generator type that has in the US right now is pressurized water reactors. So from the diagrams, the core water is held under pressure in the reactors and not allowed to boil. Then using a steam generator, the heat is transferred to water that located outside the core, thus make the outside water boiling and generate steam to power up the turbine, and the turbine will generate power electricity and supply it to the city. So the condenser here is used to cool down the steam and condense back to the reactor. So the pros of nuclear reactor is it works as a base load power with almost 100% productions, and 1 gigawatts of the reactor equals to 4.6 millions of 200 watts photovoltaic and 900 utility wind turbines. However, the water reactor will emit a greenhouse gas, which is the lowest is 1.4 gram per kilowatt and 288 grams per kilowatt. We want to avoid the highest gas emissions. The radioactive disposal will take 100,000 years to dispose, and the process might damage ecosystem of aquatic life surround the island. Now let's go over geothermal power plants. In 1994, Italian scientist Piero Conti invented the first geothermal electric powers, in which steam was used to generate the power. And the first power plant of geothermal operated in 1960 in San Francisco. So here's a diagram for the geothermal power plants. The heating boilers are not presented in this diagram because of the water that goes into Earth's surface will come out hot from the geothermal reservoirs. So to obtain the steam from a turbine, a cold water is injected down one well, and the water will circulate around the hot rocks. The hot water comes out from another well that can be used to make steam of a turbine. The turbine converts the thermal energy to electricity through electromagnetic inductions. So the well will push water from the reservoir to the power plants, and the ejection wells, which is the blue lines here, will push water back into geothermal reservoir to be used again. Most geothermal power plants will extract water and its vapor or liquid form from the reservoir somewhere in the temperature range of 100 to 320 degrees Celsius. The advantage of the geothermal is it will extract the heat from Earth without burning fossil fuels that will lead to greenhouse gas emissions. And the geothermal heat pump system uses 25% to 50% less electricity than the other power generations. The lifespan of geothermal will be much longer than other power generator. So the disadvantage of geothermal, it will release greenhouse gases apparently, and with possibility of depletion for geothermal source, and the power plant will need higher land to operate. Now let's move on to wind power plant. So the wind power for electricity began in 20th century. The first scientist that built wind turbine is Dan Polakor, and the engineer that developed the technology is Danish. The technology was used during the World War I and World War II. Wind turbine keep improving in every aspect by different engineers in order to fulfill the demand in America. So in 2010, about 40,000 megawatts been sold in the USA. But how the wind turbines work? It will generate electricity from wind turbine by converting the wind kinetic energy to the torque, which makes the wind turbine to rotate, specifically at both sides of wind turbine blade being blown by the air. The air travel across the tailing edge will create a higher pressure than the leading edge, and the difference of the pressure will make the turbine rotate. Then the energy wind is reducing when the turbine energy starts to turn and create torque energy. The torque energy will convert it to mechanical energy. Then the energy drive electrical generator to convert it to electric power. Explicitly, generator will connect to the blade using a shaft used to rotational motion to make the magnetic rotor in a generator house to spin. The rotation of the rotor generator will produce electric current by exciting the electromagnetic induction through copper wires that loop surround the generator house. In order to understand how wind power generator works, we need to understand the common characteristic of the technology. The first is the wind, the second is the physics, the third is wind power productions. So the wind characteristic has few factors for utilizations, which is wind energy that close to the ground will be utilized by the wind turbine, which affect by energy transfer from undisturbed high peak. The production of wind energy also influenced by the wind speed that vary continuously as a function of height and time. Then the very speed of the wind will affect the turbulent peak, thus impact the production of power quality. This is the formula to calculate the power, which the rho is wind density, V is wind speed, and A is the area of the blade. This is the calculation for air density. And to calculate the maximum amount of wind power, we need to use the Batts formula, because Batts, a man who discovered the theory of optimum utilizations of wind power in 1936, said that the wind power only can be extracted 59% of the total. So the reason is the speed of air mass reduced when the wind converted into mechanical rotation energy of the wind turbine rotor and completely stopped in the intercepting rotor area. So the average of the one turbine in each season is around 10 kilowatts for one turbine. The next common characteristic is wind power productions. So wind turbine power curve depend on relationship of cut in wind speed with rated capacity. The rated capacity of the turbine depends on the wind turbine design and usually reach at wind speed of range 12 meter per second and 16 meter per second. The maximum production of wind production is limited when the rated wind speed lower than the wind speed. By using pitch or stall control, the power output can be regulated. However, if the wind speed exceeds the cut-out wind speed, it will shut down the system immediately. So to restart the wind turbine, we can reduce the power production incrementally, so it will not shut down the system immediately. So the first aspect of aggregation is number of wind turbine in a farm, where the higher the numbers of wind turbine, the lower the turbulent P impact on the turbines. The second factor of the aggregation aspect is the distribution of wind farm over wider geographical area, that we reduce the diurnal and synaptic area effect due to change of weather pattern. The advantage of the wind turbine is it much more cleaner than other power plants. It's suitable both in remote area, which in our case is suitable for the island because we want to build in the region 2, and the power will be sufficient during peak hours, and it will cost less. However, for our case, we need 18,000 turbines for 200 megawatts, and it's less reliable because the wind will not constantly blow in the same speed, and it creates noise pollution, but the noise pollution is not really a problem for our cases. Now, let me get back to Larissa.
So solar was the next generation type researched. In 1876, this is a small background, William Grills, Adams, and Richard Day found that when selenium was exposed to light, it produced electricity. Then, in 1953, Calvin Fuller, Gerald Pearson, and Darrell Chapin discovered the silicon solar cell, and only 3 years later, the solar cells were available commercially. Then, between the 70s and the 90s, as we all know, the changes in the usage of solar cells have evolved to solar power. So, the way that solar power works is that for the current, it does a light-generated current where the light will hit the anti-reflecting coating, and photons will go into the substrate. And there are two important processes with the light generation current. The first process is the absorption of the incident photons, which will create electron hole pairs in the N-type substrate and the P-type substrate that are separated by a p-n junction. And the electron hole pairs need to have a greater energy than the band gap has. So the other type is a collection of carriers by p-n junction. And we want to make sure that they don't recombine. If they recombine, it won't create an electrical current. So we use a p-n junction that's wide enough to spatially separate the electron and the hole. And the emitter and base of the solar cell connected together will create a flow of the current through the external circuit. So the other thing that needs to be looked at with solar cells is the voltage, and this is done through the photovoltaic effect. A collection of light-generated carriers will move electrons to the N-type side and holes to the P-type side. This will lessen the electric field around the p-n junction because it will actually create a negative electric field and go opposite. So then it creates voltage because of the lower electric field. So here's a plant overview of a solar farm. You have your solar panel right here, and you've got it on mounting racks, and you can have mounting racks that stay, don't move, or you can have tracking mounting racks that will follow the sun through the day. And then that goes through a DC to AC converter because the electricity that is made on a solar cell is DC electricity, and our grid is on AC. So that would need to be put into a solar farm as well. And then we need to have a step-up transformer to meet a required voltage and a grid interface to go to the utility grid. So there are a few factors that affect solar panels, The first is standard testing conditions. This can cause up to 5%. This is like resistors having the plus or minus 5% rating on the shell of the resistor. Temperature can affect it up to 10%, and as the temperature inside the solar cells get hotter, that efficiency goes down a little bit. If there's dirt on the anti-reflective screen, it can affect it up to 4%. Mismatching, which is an inconsistency between modules, and modules are a set of cells together on one big plane. And wiring losses can cause up to 3% losses, and then a DC to AC conversion loss can account for 6% loss. So overall, this accounts for about a 25% loss, and it makes our efficiency about 75% of what it normally is. Solar was chosen for the island as it is renewable, and the island is mostly sunny, and we can use batteries to store the power during times when it's not needed, like when there's no sun. So the site location for this, we would need 4 square kilometers for 300 megawatts of power, which is roughly 900,000 solar panels with 72 cell modules, or 72 cells on each module. The advantages to solar power is that it's pollution-free, it doesn't cause greenhouse gases, it doesn't depend on fossil fuels or oil or any other thing, it's clean power for that. And it's available every day of the year, even on cloudy days. It may not produce as great a power as if it's sunny, but it will produce some power because sun rays are still making it through the clouds. And there's minimum maintenance on solar panels. They last over 30 years. Some of the cons are that battery bank that we would need. We would need a large battery bank to supply power at nighttime or during times when there's not as much sun making it through the clouds. And those huge batteries would need to be maintained and replaced from time to time. So this was chosen because of how reliable it is, and all the pros outweigh the cons. And then our final generation type is natural gas. We needed to supply a 600 megawatt load for this as a backup in case wind and solar cannot supply the required amounts from them. We still have natural gas to use. Natural gas isn't renewable, but it is reliable and efficient. It has quick ramp-up times of about 30 minutes, and it can supply 600 megawatts. So this is a basic overview of a combined cycle diagram. You have air coming in, and you'll have natural gas coming in here, and they'll compress together and go through a combustion chamber, and that combustion chamber will turn the natural gas into steam that's pushed through a turbine, and then it's sent out, and then there's hot air that gets pushed through a steam cycle that will heat up water that will turn another turbine and generator. And the efficiency of these systems is about 60%. So that's needed when looking at the calculations. Since we knew that we were designing this system to supply the entire 600 megawatts, we wanted an input calculation for 3 different times. 200 megawatts would be our output when both wind and solar were fully running. 400 megawatts would be when only one of those renewable energies are available, and 600 megawatts would be our output power when neither of those energies are available. So our input power would need to be as listed. For 200 megawatts, it would be 333 megawatts. For 400 megawatts, it would be 666 megawatts. And for 600 megawatts, it would be an input power of 1,000 megawatts. So the gas needed for 600 megawatts should always be needed on hand in case of times that there is no wind or solar panels available to generate electricity. So these next calculations are only based on 600 megawatts. And it's to determine how much how much natural gas would need to be imported to the island. So we use the burning rate of natural gas, which is 55 megajoules per kilogram. and we just divided our input power, which is 1,000 megawatts, by that 55 megajoules per kilogram. And then we got an amount of natural gas that was in kilograms per second. So then we had to turn that into tons per day. And after doing the unit math, we found that there should always be a reserve of 1,728 tons of natural gas for 24 hours. Now, I know that sounds like a lot, but when you're thinking about running a natural gas power plant for 24 hours at 600 megawatts of an output, so 1,000 megawatts of input, it really is needed. And according to Gatsby and how much they can supply per unit at their power plant downtown Salt Lake, we would need 9 generating units and 30 square kilometers of land for this natural power plant. So I'll turn the time back over to Jenna.
So, to conclude our presentation today, the power generation that we choose is a solar, wind, and natural gases. And because of the power supply by each generation, and the natural gas will be our base load, and the solar with wind power will be our peak load. The island will have, with these 3 generation, the island will have much more environmental clean power generations. And we choose the region 2 to put the generations because it's isolated from the city, hence reduce the noise pollutions. And the next reason is because of the winds blow from north to east is about 85% of the time. That's the reason why we choose wind power generation for our island. That's all from us today. This is the reference that we use for the project, and this is our contact information. Thank you for listening to our presentation today.